In this video, we're going to learn how to interpret a risk assessment diagram. This is a COVID-19 event risk assessment planning tool, and I'm using it not because it's a great tool, it's not, but the graphic they produced is one that's worth understanding. Those of you in the dam safety, levee safety programs are going to find it familiar. So when you get a graphic, I suggest always beginning by reading the title. This is COVID-19 Event Risk Assessment Planner. It estimates the chance that one or more individuals are COVID-19 positive at an event, given the event's size found on the x-axis and the current case prevalence found on the y-axis. So now we're going to take a look at the axes. And over here on the vertical axis, we have the active circulating infections in the United States. And it goes from 10 up to 1 million. And you know that the active infections were well over 1 million. And that's one reason why this isn't such a useful tool. But we're going to read the graphic as if the data are accurate. So what we have here are the major tick marks are orders of magnitude, 10, 100, 1,000, so on. And the minor tick marks are the increments. So this starts at 10, the first mark is a 20, then a 30, a 40, a 50, all the way up to 100. Same thing up here for 100,000, begins with 100,000, and then it goes to 200,000, then 300,000, 400,000, 500,000, 600,000. So each tick mark is another increment in this logarithmic scale. On the horizontal axis, we have the number of people who are exposed to this hazard of circulating infections in the United States. And it begins at 10 and goes up to 100,000. And it uses the same logarithmic scale. So we have 10, 20, 30, 40, 50, 60, 70, and so on. And so they've identified 5 different events, from a 10-person dinner party to a 100,000 person gathering for March Madness in Atlanta. And so we have here in the graphic, we have some lines that seem to be pretty prominent, and that's where we're going to begin. This here is the 2% line. Let's take the 2% chance line here and interpret it. What it is saying is, if we can read this vertical axis, that's 100,000, 200, 300, 400, 500, 600. If you have 600,000 circulating infections in the United States and a dinner party of 10, there's a 2% chance that one of the 10 people at your dinner party is going to be infected. If you had 100,000 people, all you need, let's see if we can read across here, if I can read across, let's see, this looks like let me count. 20, 30, 40, 50, 60, 70. So this number right here is 70. This would be 70 active infections in the United States. So if you have 70 people in the United States who are infected and a gathering of 100,000 in Atlanta, there's a 2% chance that at least one person at March Madness is infected. And any point on this line gives you a combination of infections. So let's go to 10,000. I'm just going to eyeball this. 10,000, that's about over here. And if I drop it down, that's about 800. So this is saying if we had about 10,000 people who were actively infected and you have a gathering of 800 people, there's a 2% chance that at least one of them will be at your gathering of 800 people. Now, I'm thinking this has got to be heard in your head because this is holding a lot of numbers in there that we don't ordinarily do. And so risk assessment results are sometimes difficult to process. So let's try another. We'll do the 90% chance here. Notice that this is at the 1 million point. So this is saying 1 million, and here's the reading this horizontal axis. There's 100, there's 200, there's 300. So this is about, oops, excuse me, we're on the 90%, my mistake here. So this is a 100, 200, 300, 400, 500, 600, 700, 800. If you have 1 million people in the United States who are actively infected and circulating, and a gathering of 800 people, there's a 90% chance that one or more of these people are at your gathering of 800 people. Let's take the other extreme here. Let's see, this is reading up. This is a 100. This is 1,000. So this is 2,000, 3, 4, 5, 6, 7, 8. So if we have 8,000 people in the country who are actively infected and circulating, 8,000 in the country, and we have a gathering of 100,000 people, there's a 90% chance that one or more of those 8,000 people will be at your 100,000 person gathering. And similarly, any combination of points along this line gives you a 90% chance. So if you lie above and to the right of a 90% chance, if you're in a situation like this, where I'm just now holding my cursor at a random point, that is it's certainly above the 100,000 person infected, and it's between 10,000 and 100,000 people, there's more than a 90% chance that a person's going to be infected. Let's take a look at these scenarios. There are two that have been worked out for us. This is showing 2,000 cases. And as we scoot on over, it's saying if you have a dinner party of 10 people and there are 2,000 cases, there's a 0.0061% chance that one of the people there is infected. If you have 100 people, it's a 0.061 chance. 1,000 people, a 0.6 chance. 10,000 people, it's a 5.9% chance. And if you have 100,000 people, there's a 45% chance that one or more people will be infected. Notice that this 5.9% chance falls between the 2% chance line and the 10% chance line. So this is just interpreting this white space in here. The 20,000 case scenario does the same thing. It says if we have 20,000 actively infected people in the United States and a dinner party of 10 people, your risk of having an infected person there is pretty small, 0.061%. If you have 20,000 cases and you go to March Madness, there's a 99% chance that there will be at least one infected person there. So notice that this point lies in this area above the 90% chance line. So these graphics, they can be difficult to interpret. Sometimes they're so difficult to interpret that it's hard for risk managers to make decisions based on them. The U.S. Army Corps of Engineers uses graphics like this for their dam safety and levee safety programs. And I think many of the people, if not all of the people in the program, are comfortable with and understand those graphics. But to others, they remain a mystery. So take your time with the graphic. Begin by reading the title, understand the axes, and then just go slowly through what the lines represent. By the way, this line here, this heavy line, it's not labeled, so we'd have to be a little bit reluctant to interpret that unless you read this down here. This says this gray area has less than a 1% chance of COVID-19 positive attendee being at your event. So this must be the 1% line. Even though the line itself is not labeled, this little notation here kind of indicates that this is the 1% line. So if less than 1% chance is considered an acceptable or tolerable risk, then anything that lands in this gray area would be safe to do.